So each of the equations in part 1 that we graphed were written in general form. And when an equation is written in general form, meaning a number plus x plus a number plus y equals to a constant, plugging in 0 for x, 0 for y, and then some random number is not a bad strategy. The next few equations are going to be written in slope-intercept form, meaning they're solved for y. That strategy of plugging 0 in for x, 0 in for y, when something's solved for y, makes little sense, and you're probably going to get fractions that you don't want to. The next few equations, because they're solved for y, I'm just going to pick 3 numbers and plug them in for x. Probably just going to pick 0, 1, and 2 and plug them in for x, but maybe I'll tweak it every now and then if that might cause a fraction, and I'll show you when it might cause a fraction. So problem 10 is written in slope-intercept form, and it's not a number in front of the x, which is a good thing. So let me just do that. So if an equation is written in slope-intercept form like this is, plugging in 0, 1, and 2 for x is not a bad way to go to find my 3 points. If the equation is written in general form, plugging in 0 for x, 0 for y, and then some hopeful number that doesn't give a fraction is a nice way to go too. Idiot. So slope-intercept form, it's so much nicer. You might know a strategy for graphing already that has to do with plotting a point and using something called a slope. We'll learn that. If you know how to do that, then don't do these points. If you know another way, I'd love you to use that way if you remember it. But I'll teach you it. It's just too early to teach that method right now. So either I'm going to make a little t-chart, or I'm going to do the points by hand and write them as points. My first point, I'm just plugging in 0 for x. I like to keep the numbers small because they're easy to work with when they're small. And the algebra, when something's written in slope-intercept form, is easier. So when I plugged in 0, which is the number I like to plug in most because it gives me the easiest algebra, I did the algebra and got -3 for y. So my point was x equals 0, y equals -3. I'm going to plot that point and mark it. Now x equal to 1. Get y equal to 5 times 1 minus 3. Everything about the general form is pretty awful. Everything about slope-intercept form is pretty nice. Slope-intercept form is my preferred equation for a line. Slope-intercept form, we'll talk about slope and intercept in a little bit, but not right now. It doesn't want to overwhelm you. So algebraically here, I plugged in 1 for x and got 2 for y. So the next point I'm going to plot is a point 1, 2. So x equal 1, y equals to 2. I'd like to write my points down along with marking them. And then lastly, y equal to 4. Y equal to x equal to 2. My gosh, I don't know what the heck I'm thinking. My third point's going to be 2, 7. And again, if your points don't line up perfectly on a line, if you're using graph paper, then you've made a mistake. Found my ruler, so now I can plot the points with a little more precision. Still not even perfect. I have a tendency to not like things being out, so I was using this ruler the other day, and I put it away. I'm really good about putting stuff away, not necessarily that good about knowing where I put what I put away. That would drive my ex-wife, oh my gosh, you can't imagine how crazy it would drive her. She would have the habit of leaving items out for 5, 6, 10 days at a time, and I never have things out, so eventually I would just put her stuff away for her, and I wouldn't always remember where I put it, and that wasn't good. Anyways, I'm going to skip 11 and 12 because I don't want to graph every single problem. There's just too many. And move on to 14 and 13, better problems, because if I just plug in 0, 1, and 2, this is written in slope-intercept form. If I just plug in 0, 1, and 2, because of that fraction, I'm going to get a fraction. So in order to avoid plugging in fractions, any number I plug in for x, I need to multiply it by 1/2 and not get a fraction, which means I need to plug in even numbers or multiple of 2. So 0 is probably never going to fail me, but if I did 1, it would fail me in the sense that I might get a fraction. So the numbers I'm going to plug in instead of 0, 1, and 2 are 0, 2, and 4, because when I multiply by 1/2 these numbers, I won't get a fraction. So if I could do a table like this, x equal to 0, x equal to 2, x equal to 4, but you can do 0, 1, and 2 every time if you don't mind plotting fractions. So my first point, I'm going to plug in 0 for x. I love plugging in zeros when they don't give me fractions. If I plugged in 0 for y, the algebra would be ugly, or uglier than I care to do. The algebra here gave me y equal to -5. I started off with x equals 0, so that point, I would call that a y-intercept. It's on the y-axis, is the point 0, -5. Always, if you pick a letter and plug a 0 in for that variable, it will graph on the opposite axis. So plugging in 0 for x gives me a point on the y-axis. It's called a y-intercept. Now I'm going to plug in 2, get y equals 1/2 times 2 minus 5. If you need your calculator, pull it out and use it. I don't have any issues with that. So if you're not comfortable figuring out 1/2 times 2 minus 5, I don't need to see any work here. I just need to see the points. I have no problems at all with you using a calculator. If it speeds up and makes your work more accurate, so be it. So I plugged in 2 for x, got -4 for y. And watch me do the next one just without even showing any work. I'm going to go 1/2. I'm going to do 1/2 times 4 minus 5. I don't need to see any work. Here, this gives me y equals to -3. That's going to be the point for -3. So be as lazy as you feel comfortable with your calculator. So let me plot these points. So 2, -4. I always like to write my points down, but you don't really have to. A dot is sufficient. And 4, -3. If your points don't line up, then you've made a math error somewhere. And if your line doesn't go through the points perfectly, it's not such a big deal. Like, I'll just make the points bigger to make it look like the line goes through them. I always throw the arrows at the end of my lines if I'm thinking about it. Let's do 15 together. 15, because the fraction in front of the x has a denominator of 3, plugging in multiples of 3 would be good for my values, because a multiple of 3, the 3 will cancel with it, and I won't get a fraction. So let's do maybe let x equal to 0. Feels good for 15. Let x equal to 3, which is a multiple of 3. I almost never plug in fractions. I almost never plug in negative numbers. I usually like to plug in positive integers that avoid fractions. So in terms of a table, I'm getting an x of 0, 3, and 6. For each x, I'm going to get a y. And first one, negative fraction 1/3 times 0 plus 7. My first y is going to be 7. I have no problems at all with you just generating the y's with your calculator, not showing a lick of work. And watch this. Now I'm going to use the little back arrow, this little mouse key, go to the 0, change it to a 3. So that's -1/3 times 3 plus 7, because we're doing, let me just cross that out, we're doing that one. And that's going to give me y equal to 6. That's the 0.36. And now let me change the 3 to 6. That's -1/3 times 6 plus 7. That gives me y equal to 5. That's going to be the 0.65. The last one I just rushed through, it gave me the 0.36. So that's enough for me. I don't need to see all the arithmetic. You can do the arithmetic by hand if you care to, but I don't have any issues with you using your calculator. First point's a y-intercept. When I plug 0 in for x, I get a number on the y-axis. A point on the y-axis is a y-intercept. So 0, 7 is my first point. 3, 6 is my second point. It's a lot nicer having a graph made up ahead of time. And I actually physically graphed all these ahead of time to see what numbers I needed on the axes to make my graph fit, so that I didn't have to fuss in the video. Again, this is, for me, these are good graphs. Trust you me, boy, they can get really ugly. So that we're up through 15. We're pretty deep into this. The next problems physically want me to find the intercepts. So now I've kind of mentioned this informally. Now we're going to formally talk about this. An X-intercept, it's a point that has a 0 for the y, and it's where the graph crosses the x-axis. So any point that's on the x-axis, so if I made a graph that looks like this, let's say this point right here is 1, 2, 3, 0. This point is in the form some number called 0, 0. It's on the x-axis, so this would be called an x-intercept. Algebraically, I find x-intercepts by plugging in 0 for y. Let me make another point up here. Say this is the point 0, 4. Any point that's directly on the y-axis is called a y-intercept. And what the intercepts have in common is they all have the opposite letter or the opposite variable 0. For x-intercept, it's a point on the x-axis, the y is 0. Y-intercepts are points on the y-axis, the opposite letter of y, x is 0. And that's what this says here, but it says it wrong. It says the y-intercept is some point 0b. It's where the line crosses the y-axis, and it happens when x equals to 0. You find intercepts by plugging in zeros, and that's what we're going to do next. We've done a couple of these already. We'll just do a couple of more. So the next problems, they formally tell me this is what I want to do. I have an equation written in general form. This is a nice bit of algebra. So 17 through 32, the instructions have changed. They specifically said find the x-intercept. The x-intercept is going to be some number, comma 0. Find the y-intercept. The y-intercept is going to be 0, comma some number. And then some random other point and sketch the graph. So for part A of number 18, I've done this already. This isn't new. To find the x-intercept, I let y equal to 0. So I'm going to go x plus 3 times 0 equals 9. Always when I'm finding an intercept, I'm plugging in a 0, and it's the opposite. If I'm finding an x-intercept, I plug 0 in for y. So my x-intercept is going to be the point x equal to 9, y equal to 0, because algebraically I put 0 in for y, so the y coordinate of my point is 0, and I got 9 for x. So right on the edge of my x-axis, I get the x-intercept of 9, 0. Part B of 18 asks me to find the y-intercept. Always when I'm finding intercepts, I'm plugging in 0. For the opposite letter of y is x. Algebraically, I'm going to go 0 plus 3y equals to 9. That's going to give me 3y equals to 9. I'm going to divide by 3. That's going to give me y equal to 3. As a point, I plugged in 0 for x, so the x is 0. I got 3 for y. The y is 3. So the answer to part B, the y-intercept is 0, 3. It's a point on the y-axis. And then, because the x doesn't have a number in front of it, if I plug any number in for y, I won't get a fraction. So for my third point, for 18C, I'm just going to let y equal to 1, plugging any number in for y, because the x doesn't have number to divide by to solve. It's going to be golden. I won't get a fraction. So x plus 3 times 1 equals 9. X plus 3 equals to 9. Minus 3, x equal to 6. That's the point, x equal to 6, y equal to 1, because I said y equals to 1 was what I was doing, and the x came out to be 6. And again, you can tell real quickly if you have a mistake, because your points won't line up very nicely. Let's do 19 together. 19, I just wrote up the solutions, and I had a mistake on my solutions, and I just changed the problem. So 19 is supposed to be 3x plus 2y equal to 24. The reason that plus looks funky is because there was a minus there. My solutions manual was wrong. I didn't feel like changing it. So let me do 19a, or you can do 19a. I'm going to find the x-intercept. I find any intercept by letting the opposite letter be 0, so I'm going to let y be 0. I'm going to go 3x plus 2 times 0 equals to 24. This 2 times 0 is just 0, so it's going to give me 3x plus 0 equals to 24, and that's just going to give me 3x equals to 24. Divide by 3, I get x equal to 8. The answer to part A for number 19, the x-intercept is the point 8, 0, because I plugged in 0 for y and got 8 for x. For 19b, to find the y-intercept, always when I'm finding intercept, I let the opposite letter be 0 or the opposite variable be 0, so I'll plug in 0 for x, go to this equation, and go 3 times 0 plus 2y equals to 24. This piece is just going to zero out. It's going to turn into 0 plus 2y equals to 24, and it's just going to go away because it turns into a 0, and anything plus 0 is itself. And now I didn't leave myself enough room. Well, it's because I didn't plan on doing this problem. I planned on doing my problem. So I get y equal to 12 here. That gives me x equal to 0, y equal to 12. I plugged in 0 for x, got 12 for y. So the y-intercept is the point 0, 12. Didn't plot the x-intercept even. That's okay. Let me get these plotted. X-intercept is the point on the x-axis. I find 8 on the x-axis. And then the best I can, I estimate 12 on the y-axis. I didn't plan ahead to do this problem, so I fudged up a little bit. And the y has a 2 in front of it. The right side is even. If I make the left side even, if I plug a number in for an even number in for x, I won't get a fraction. Because if the y has a 2 in front of it, plug any even number in for x and you won't get a fraction. So for my third point, I'm going to let x be 2 and do 3 times 2 plus 2y equals to 24. That's going to give me 6 plus 2y equals to 24, minus 6 gives me 2y equals to 18. You don't need to show this much algebra. I'm just showing it in case you want to see it. That gives me y equal to 9. I plugged in 2 for x and got 9 for y. So my third point is 2, 9. So x equal 2, y equal to 9. If you just make a dot and don't show the point, I don't care. So I'll just do that just to show you that that's okay. And now the best I can, and probably not the best that you can, but it's the best I can, I just connect the points. 21 and 22, they're essentially the same. You could skip 21 on the homework. I'm not wanting you to graphs. There's too many graphs here, I think. I overshot on the number of problems. But I want to do one that's in slope-intercept form. Slope-intercept form is not as nice for finding intercepts, and sometimes you get fractions, but we're at the beginning. I tried not to make fractions. Same instructions though. General form is nice for finding intercepts. Slope-intercept form maybe not as nice. But for 24a, I'm going to find the x-intercept. I find the point where the graph crosses the x-axis, which is the x-intercept, by letting y equal to 0. So algebraically, I'm going to go 0 equals 4x minus 16. And then I could do the algebra in my head. You don't need to show me the algebra if you could do it in your head. But on a test, if you do algebra in your head and you make a mistake, it makes it harder to give you partial credit. So the only, saving grace for loading up the amount of work that you show is I'll give you partial credit for mistakes. But simple algebra, two-step algebra that you can do in your head, if you're so inclined to do it in your head. So I plugged in 0 for y for part A to get the x-intercept. 24b wants me to find the y-intercept, so I'm going to let x be 0 and go y equals to 4 times 0 minus 16. That's going to give me y equals 0 minus 16. That's y equal to negative 16. So I plugged in 0 for x and got negative 16 for y. So my y-intercept is the point 0, negative 16. So I'm going to find negative 16 on the y-axis. I didn't even plot the x-intercept yet. I'm guesstimating. When I tried to increment down by 1, the numbers got too close together. It was ugly. So I incremented the y-axis by 5 to make it look nicer. Let me plot that x-intercept. Because this equation is in slope-intercept form, there's a little danger in plugging in values. If I plug a value in for x, I shouldn't get a fraction unless the x had a fraction in front of it. So for my part C, I'm just going to let x be 1 and go y equals to 4 times 1 minus 16. When my equation's in slope-intercept form, I like just jamming numbers in for x. When I plug the 1 in for x, I got negative 12 for y, so that represents the point 1, negative 12. And as a point, go right 1 down, estimate 12, best you can. Again, I didn't write the values in. You don't have to. I kind of like writing the values in, but we're not doing anything with these graphs. We really don't need to know exactly what the values are. Little arrows at the end of my line would be nice. All right, let's skip 25 and 26 and let's worry about a couple of fractions. 29, 30, 27, and 28 are fractions. I'll do 28 and then I'll do 29 and then we'll bust into the part 3. So slope-intercept is not really the best for finding intercepts, but I'm going to do it. So for 28a, I'm going to find the x-intercept by letting y be 0. This is the hard part. We have to remember stuff from the last chapter that you hopefully haven't forgotten. I forget what section it was. I think it's 2.1. So this is bad solving. I plugged in 0 for y. And that forced me to add 10 to both sides, and I got 10 equals 1/2 y. When there's a number in front of the 10 equals 1/2 x, when there's a number in front of the variable that's a fraction, you have to multiply by its reciprocal to solve. So I multiplied both sides by 2 over 1, and on the left side, that 2 over 1 is really just 2. So that's going to give me 20. And on the right-hand side, the fractions cancel, and I'll get my x. This is going to give me the x-intercept of 20, 0. I clearly didn't plan ahead because this doesn't work. But I'll figure out a way to get this graphed. I might have to re-increment my x-axis to make it work. In fact, that's what I'm going to do. I'm going to say this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I'm going to plot my point 20, 0 on my newly developed x-axis. I'm going to delete these points because I don't think I'm going to need them. Yuck. 28b, I want to find the y-intercept. So I let x be 0, and that's a lot easier. I'm going to go y equals 1/2 times 0 minus 10. And that's just y equals 0 minus 10, or y equals negative 10. I plugged in 0 for x and got negative 10 for y. So my y-intercept is the point 0, negative 10. And I left myself room for that. If you're living dangerously, you really don't need a third point. I just like doing the third point because it makes it so I don't make as many mistakes. And since the equation is solved for y, I want to plug a number in for x. The fraction in front that has a 2 in the denominator forces me to put a multiple of 2 in for x to avoid fractions. And I'm just going to plug in x equal to 2 and get y equal to 1/2 times 2 minus 10. When an equation's in slope-intercept form, meaning the y is isolated, I almost exclusively plug numbers in for the x to find my points, unless I'm finding an intercept and I am told to do something different. This right here, let me just do this now. Fraction 1 over 2, idiot, 1 over 2 times 2 minus 10. The y is going to be negative 9. So this represents the point 2, negative 9. That's my additional point. So x equal to 2, y equal to negative 9. And you get worried when the axes aren't incremented the same. Are the points really going to line up? But they should. But without graph paper, having points this far apart and having them line up, that's not so likely. If I was doing this without graph paper, the chances of my points lining up are pretty close to 0. So we're going to do one more problem and then we'll break into a part 3 for this video, and I'm going to do 29 with you. 29, because it has a fraction that's ugly, it wants me to find intercepts. For part A, I'm finding the x-intercept for 29, so I let y be 0. That gives me 0 equals negative 1/3 x plus 15. I'm going to minus 15 from both sides. My go-to is get the constant separated from the variable. And when the variable has a fraction in front of it, you have to multiply by the reciprocal. So I'm going to multiply both sides by negative 3 over 1. On the left-hand side, the negative 3 over 1 is really just negative 3 because a fraction with a 1 in the denominator is just the numerator. So this is going to give me 45. I definitely don't have, well, I do have room kind of for 45. On the right-hand side, the fractions cancel and I'm left with the x. So my x-intercept for problem 29 is 45, 0. Let me extend this. This is 35, 40. I increment it by 5. And that's, you're going to have to do that to get way out this far. Part B of number 29, I'm going to let x be 0. That's going to be easy. I'm going to go y equals negative 1/3 times 0 plus 15. This piece comes out to 0, so you just get y equal to 15. That's going to represent the point 0, 15. Doesn't quite fit on my graph. I was going to do 30, but that's okay. There's 15. There's my point 0, 15. And for my third point, it's in slope-intercept form, so I'm plugging a number in for x. And the denominator there is a 3, so I need a multiple of 3. I'm just going to let x equal to 3. Any multiple of 3 is going to be good. I'm going to get y equals negative 1/3 times 3 plus 15. Calculator worthy. Negative fraction 1 over 3 times 3 plus 15 gives me y equals to 14. That represents the point x equal to 3, y equal to 14 for my additional point. So x equal to 3, y equals to 14. I have to guesstimate 3, but I don't have to guesstimate 14. So I've guesstimated my points the best I can. Didn't even mark the point 45, 0. I just went ahead and shoved it in. And then I'm just going to make sure my line goes through the points more or less. Draw little arrows at the edges of my graph to indicate that it doesn't stop. You can try 31, and we'll move on to part 3. Don't skip part 3 because it has a really important concept of vertical and horizontal lines. It's the one of these things is not like another in this chapter, vertical lines and horizontal lines, and you don't want to skip that video. And if you're burned out, wait till you're fresh to watch it.